All right, so today we're starting with this thing called warm-up. And the first one was as simple as a V-shape because its parent is an absolute value function. And I know those are V-shapes. And then it's been moved to the right 3. That might seem like left 3. We remember to not trust the inside. So it's right 3. What if I needed proof? Like I'm on the test and I really feel like that's wrong. Let me show you. You can stick in any number you want. Like let's say I stick in 5. And then you go, 5 is for x, 5 minus 3 is 2, and y is the absolute value of 2, which is 2. Is 5 2 on my function? Yes, it is. See, it's right there. See what I did there? I just picked any point I wanted. I stuck it in. I stuck in a 5. I got a 2. 0.52 is on my graph. I'm probably doing it right. All right, now, on the test, though, you'd have to give me 5 points. Well, here they are. 3, 4, 5 points. Okay. Would you please try this one with an XY chart? I doubt many people are going to go, oh, it's a square root graph that I have memorized, and it's moved down too. That is true, but I think you're going to need to find points. I'll walk you through one of them. I'm going to pick one of the weird ones that usually people forget about. 0 works because if I put in x as 0, the square root of 0 is 0, and that's not illegal. 0 is a number. 0 minus 2 is negative 2. So 0, negative 2 is right there. Now, can you find me a few more points? Take a second. Find me at least 3 more points. Come on up and grab the charger. They don't deliver. All right, walk me through putting in a point. You can put in any number you want. Just don't put in numbers that are hard, like 5. Like, why would you want to do the square root of 5? Nobody knows what that is. So, Amina, give me a number you could put in here. Okay, square root of 2. You know what the square root of 2 is? No, so then don't pick 2. Give me something else. 4 would work nice because the square root of 4 works nice. What is the square root of 4? 2. And then do the minus 2. 2 minus 2 is? So we put in 4, and now we have 2 minus 2, which is 0. 4, 0 is a point on your graph. So 4 worked. Because the square root of 4 works. Zane, give me another one. Louder. 9. Okay, square root of 9 works. Because square root of 9 is 3. 3 minus 2 is 1. 9, 1. Now, it does go off the graph. But it'd be like there-ish. One more that would have worked pretty nice is 1. How many of you knew that 1 would have been smart to put in? For future reference, you'll have to know 4 things that have nice square roots. 1 has a nice square root. What's the square root of 1? 1. And then 1 minus the 2 makes, well, I put in 1, and now I have 1 minus 2, which is negative 1. 1 negative 1 is right there, and this should look familiar. That is the square root graph. Kind of looks like a ramp going up to the right. But this one seems to be moved down. Look at it. Doesn't it make sense? It's got the minus 2 at the end. This means down 2. So look at it. It moved down 2. It used to be here. It moved down 2. All right, on to number 3. Now the teacher squeezed in a little squared there because that means the parent graph would be a parabola like this. And the teacher wanted you to be able to move it 2 ways. That 1 in there is left and right. And I don't even want to ask a kid, to be honest, because so often the kid just like, I don't know. So think it through. You don't trust that 1. So first you should be thinking, okay, I got to go left or right. And positive 1 is over here. So it should seem to you like it moves to the right. How many of you knew it was actually left 1? Okay, good. Okay, and that you trust. It's because it's on the outside. And that means up 2. Seems like up 2, and it is up 2. So it's going to go left 1 and up 2. So my U shape is going to go left 1 and up 2. I'm just going to move its like little vertex. Left 1 and up 2 is right there, and then my parabola goes like that. Is that good enough? No. You have to have an XY chart. And you actually have to have 5 distinct points. For this test, I think more than any test we've had so far, math is going to reward the careful people. Because if you just slap your graph in quick like this, I can't give you the credit. You've got to be like really perfect about exactly where each point is. And this one's off a little bit. So I'm going to put in -1 as my first point. I'm supposed to put in at least one negative number. And then I'm going to put in 1. I'm going to put in 2. Please try that. Find me a bunch of exact points. Making your XY chart is going to keep happening all the way to pre-calc. I'm telling you, some of you guys aren't even going to get to pre-calc for 2 years from now. Some of you are going to take FST next year and then pre-calc the year after that. The top students in here are going to take pre-calc next year. All right? When pre-calc comes along and the graphing happens, it's XY charts. You got to get good at this. It's going to keep happening all the way through high school.
Wait, what's like the next one?
What's what?
What's like the next math?
Oh, the next one after this is either FST or you could take pre-calc.
What's FST?
I know up till this moment you never had a choice. The teacher just said this is the math class. Did you know that after you take this class that you will have literally 7 choices of math class you can take? You have a ton of choices. You could take 3 different versions of pre-calc. You could take FST. You could take an IB class. You could take a different IB class. You could take math of home renovation. You could take stats. You could take AP stats. All of those things after this class. But it's going to be based on if you did really well in this class, then you could pick any of them. If you really struggled in this class, then you'll probably take FST. That's going to be at least 10 to 15 kids in here are going to take FST next year. All right. So, can you stick -1 into this? If you can't, then you're probably not headed to pre-calc next year. You got to be able to stick a number into a function. That's pretty easy, isn't it? Okay. Since I just started with that's pretty easy, isn't it? I probably shouldn't call on anybody. Otherwise, if they get it wrong, they're going to feel really bad. So please, somebody who's confident, tell me how to put -1 into this function. Raise your hand. Have some guts. Nichols.
First we do then plus in parentheses put -1 plus 1 is 0.
That's 0.
And of course if you times it by 0, it's just 0.
So 0 squared is still 0. Keep going.
So it's just 2. Y equals 2.
Plus 2. So y equals 2. And then I graph the point -1, comma 2. Wait a minute. I was already there. Awesome. There is a point in that spot. It makes sense. Chloe, can you put in a number for me? Have you got another number? Tell me a number you put in.
1.
+1. When you put a 1 in, walk me through it. And then square it.
4.
Plus 2.
6.
So you put in 1, you got 6. There's a point, 1 comma 6. Over 1, up 1, 2, 3, 4, 5. Ooh, look. That's where it actually was. And I had probably not put it in the right spot. See, my graph was off a little bit. So just kind of slapping the graph in there. It's kind of nice to know what they generally look like. But you got to get exact points. All right, carry in. Put in the 2. Step up. Two plus 1? Square it. 3 squared. 9 plus 2. 9 plus 2? Okay, so 2 comma 11. Wait a minute. I put in 2 and I got 11. Something's wrong. Oh, well, it's just off the graph, that's all. But there is something wrong in my actual graph. That spot that I put a dot at, that wasn't 1 comma 6. That was 0 comma 6. I apologize. 1 comma 6. Over 1, up 6. 1, 2, 3, 4, 5, 6. There we go. All right. Couldn't you put in 0?
Props.
Did anybody put in 0? What'd you get? Just, you can go right to the ending.
I got 4.
All right. I'm pretty sure 1 squared is 1.
I got 3.
There we go. 3. 3 makes more sense. 0 comma 3. Did anybody else have 0 comma 3? Yes, there's several hands. All right. 0 comma 3 is right there. And look, this is just the right side of the parabola. Now, of course, there's going to be a left side of the parabola, and I can even just look and go over 1, up 1, over 2, up 4, and I can tell where it's going to be. Now, if you didn't understand how I got those, you could put in the number -2, and you would have got -2 up here. -2 plus 1 is -1. -1 squared is 1. 1 plus 2 is 3. And that's how you get this spot right there, is -2 comma 3. Okay. And last thing, let's jump to number 5. See if you got domain arranged down. Caden, domain. What's it about?
Left to right.
Good. On this problem then,
What
this is
doing?
number 5.
Yep.
How far left does it go?
Number 5.
Yep. Buying time. It's okay. Look at it. How far left does it go? Does it go forever to the left? Is there an arrow that like tells us it goes forever to the left?
No,
No, so it's not an infinity.
it says 0.
You are correct. Now, it's because it goes from there, which is 0, to there. So it's the domain, Caden.
0, 16.
And now, which one of them does it touch? Because it matters on brackets or parentheses.
16.
It touches the 16. Why? Can you tell me why?
Because the circle's filled in.
Very good. Bracket here, parenthesis there. Nice. All right. Maura, in the front row, Maura. Can you tell me which is the range?
-32,
From a low of -32. Keep going, you're doing good.
-4,
And which of them has a bracket?
-4.
Yep. Because it touches that spot. That was from this low to this high. All right. So enough about that. What's the new lesson for today, Mr. Silver? Let's get on to the new stuff. All right. The new stuff is as easy as this. Do you know what this looks like? If not, you're behind. You got to know what that looks like. It is a U shape. Now that I show it to you, do you understand what I mean? Parabolas kind of look like a U. The other two main ones we do are a V shape for absolute value and a weird ramp shape for square roots. Are you good with those 3? You got to know those 3. Okay. Then what do you think happens when I put a negative in the front of that x squared? What does it feel like should happen? Doesn't it feel sort of like it should be the opposite of the way it is?
No, because it's a positive either one.
Interesting. Okay, I see what you're saying. Don't negatives mean opposite of? I can make it do what you just thought. What you thought is that I had it in here, because then if it was inside there, then when I square it, the negative won't even matter. But I think you thought it was like that when there isn't any parentheses. If you're going to put any parentheses at all, a variable is an empty parentheses, so the negative is on the outside, so it does matter. Yes? Yes, it goes upside down. Like that. Opposite of means it's got to be the opposite. Well, the opposite of what? Well, opposite kind of the direction it was going. Instead of going up, now it's going down. Now, let's see if that fits with the stuff I told you before. Do you remember me saying high, horizontal inside, vo, vertical outside? That is called a vertical reflection. Now, I don't know yet whether we can accept the word flip. It does flip. If we just are talking in like one kid to another, it flipped. That's true. But the official word is reflection. In honors, we have to mark the word flip wrong because they're expected to know the official term is reflection. I don't know yet. So I'll tell you later whether it's okay to even say flip on the test. But if you said it had a vertical reflection, I for sure would mark it right. Okay? And that's the only thing that's new today. If we put a negative on it, it's going to flip. Now, there is two ways to flip. Let me show you. Picture that graph being flipped. You should probably say, which way do you want to flip it? Because I could flip it this way. You see what I did there? Would you agree that was kind of a left-right kind of flip? Which is called a horizontal reflection. Or I could flip the green one this way, which is kind of up and down kind of flip, which is called a vertical reflect. So if this is your starting function, it's the parent function, then this one has a negative on the outside, and this one has a negative, take a guess. The other one had a negative on the outside. The red one's going to have a negative on the inside. Hold on just a second. I'm recording the video. Okay, so we have now got a regular starting function right here, and then it could be flipped this way, which has a negative on the outside, or this way, which has a negative on the inside. All right, let's see if you can do it with a V. Here's a standard V graph. It is an absolute value. Y equals absolute value of X. Are you with me so far? So what if I said, I want you to take your function and I want you to put a negative on the outside? You'd have to ask yourself, what's the outside? Well, that means like out here. And then you'd have to ask yourself, did he just tell me to do a horizontal or a vertical flip? Because there's two kinds. What kind is that? Yes.
A vertical flip?
Yep. Because that's on the outside of the parentheses or the brackets or the square root. It's on the outside of them, no matter what. So that is a vertical on the outside. That's a vertical reflect. And then do you get that the graph would look like that? Now, this is the kind that Mr. Nichols was talking about before, where if I put the negative on the inside, nothing would happen. I want you to think about that for a second. If you put a negative on the inside, it's supposed to flip. But do you get if you take this V and you flip it this way, that the new graph is going to be right on top of the old graph? It's going to be exactly in the same spot? Does that make sense to you? Now, why, if I put the negative on the inside, why should it not matter? Because it's an absolute value. Think about it. If you make the inside negative, doesn't that just, negative just gets kind of like chopped off when you do the absolute value? Yeah. When you do absolute values and negatives, they become positive again. It's like you never even did anything. So when you have a negative on the inside, that's a high, horizontal inside. horizontal reflect, and on this problem, it wouldn't do anything. Because it would flip right back onto itself. Okay, what about an x squared? Is there an inside and an outside? Yes, there definitely is. If I put a negative on the outside, it takes your U shape and flips it. That was way too sloppy. I'm gonna try again. There, and there. Is the official word flip? No, what is it officially? Reflect. And this is a vertical one. Good.
Now,
But if I put the negative on the inside, would it flip? Well, it would flip. It's just that it would flip right back onto itself. So this, a left-right flip on this thing, a horizontal reflection, would take this side and flip it over to there, and this side to flip it over to there. So it's right back on top of itself. It's like it never moved. Because if you have a negative number and you square it, the negative goes away. It's like you never did anything. Okay, so at this point of the test, you'd have to be able to tell me this. Which way did this thing move? Well, it was a V shape, and then it moved this way, and then this happened. Don't say it. Write it. This is a typical question you'd have to be able to answer. What happened to the V shape? Okay. Bennett, tell me one thing that happened. Write this down.
it reflects itself.
Okay. Which way? You are correct. High vo might help. Horizontal inside, vertical outside.
Below it.
There's inside and there's outside. There's no below. Is this a vertical reflection or is it a horizontal reflection? And think about high vo.
Vertical.
It is a vertical because it's on the outside. So it's a vertical reflect. The other thing is tricky, Josh Lipnick. Why? Why is this tricky? Kids, half the kids are going to get it wrong. You think it goes one way and then it goes the other way, okay? What do you think it does actually? It does go to the left. Left 3. Good. Because plus 3 seems like it goes to the right because positive 3 is over to the right. But it actually goes to the left. There you go. Raise your hand if you had that one right. Okay. So if you actually had to graph this, that is absolutely something we could do on the test. And you go a V shape that got reflected and moved to the left. Would you please sketch that? This is a sketch. They can be really quick and easy. Just move the V and reflect the V. Mara, stay with me. We're almost done. In a moment, I'm going to ask you to show the kid next to you or ask them for help. Some people did the wrong kind of reflect, I saw when I looked. This is a vertical. Vertical leap is like how high up and down you can leap, right? So it's an up and down thing. Okay, please compare with the kid next to you. We are pretty much done. See if you've got this.
Okay, 7 to 6.
Well, I thought the whole thing is
Yeah,
if
yeah.
it reflects,
I
it'll
think,
be,
wait, can I do it?
it needs something to
Let me try it. Only we want the dots.
Upside down.
Dude, I cannot.
Maybe you can draw it.
Yeah.
All right. Here's the vertical reflect. It's an upside down V now. And then it's left 3. Final answer is this green one. It's an upside down V, move to the left 3. Raise your hand if you had it right. Okay, good. All right, so there's a Schoology quiz. It's your homework. You got a bunch of time to work on it. This is the part where you should come up and ask me one-on-one questions. If you get stuck, please open the Schoology quiz right now. I'm able to tell who has and who hasn't opened it. So kind of not fun to be called out on that, and I will. So get your Schoology quiz open now.